So welcome in the next video of our video series on refraction of light, and we learned what our lens is. We have done our recap, and let's dive straight into some definitions, some things that are related with lenses, and let's see what they are. Okay, so as we talked about that we are talking about spherical lenses, right? Lenses that are made of parts that are spherical, right? Or maybe I should just copy this and paste it here. Okay, so we talked about how these lenses are spherical, which means that they are made up of parts of a sphere, right? Part of a sphere. So let's pretend that these two circles are two spheres that are colliding together and are sort of overlapping into each other. Okay, so what we can see that there is this shape that sort of resembles the shape of the convex lens that we see in the last video, right? That we saw in the last video. Okay, so we can define some terms here. And I don't want you to rote memorize those terms. I want you to see what those terms actually mean and then make your definitions on your own, right? That's the best way of learning definitions, that see what they are and then describe what they are in your own words, and that's the best part here. Okay, so these two circles are overlapping, and this particular part is made up of this circle as well and this circle as well. Maybe we should call them spheres because we are calling them spherical lenses, right? So let's say that we have a center here and we have a center here, right? These two spheres have a center, of course, right? Circles and spheres have their centers. So these centers are basically called the center of curvature, right? Each of these surfaces form a part of a sphere. The centers of these spheres are called centers of curvature of the lens, right? So we have this particular center and this particular center. Maybe we can call this C1 and maybe we can call these C2. Okay, and then we can take a pencil and we can mark them just like this, and we can write here center of curvature. Okay, now let's take another a new color and let's define the other term. The center of curvature of a lens is usually represented by C, right? And since there are two centers of curvature, we may represent them as C1 and C2. Okay, we can imagine a line that is passing through both of these centers, right? Let's take this particular thing and then we can imagine this line, right? We can imagine this line, we can sort of straighten this and then we can, okay, right? So this particular line, okay, this center may not look very centered so we can make this a bit properly. Okay, so this particular line, and what is it called? This line is called, what is this line called? This line is called basically an imaginary line passing through the two centers of curvature of a lens is called principal axis, right? This is called as principal axis, right? Okay, so two definitions are done. Okay, the central point of a lens is its optical center. So what is the central point? The central point is this. The central point is basically this. Okay, this particular, we like mention it by drawing an O. We mention it by drawing an O. Okay, and we can write this as the optical center. And these terms are important because these terms will be used when we talk about the image formation by a lens. Okay, represented by the letter O. A ray of light through the optical center of a lens passes through without suffering any deviation. Okay, so that's the particular rule that we'll learn in the image formation. Here we're just going to talk about the terms. Okay, the effective diameter of the circular outline of a spherical lens is called its aperture. Okay, so what is the effective diameter? The effective diameter of the circular outline, right? So what's the circular outline here? What's the circular outline here? Let's take another color, right? This circular outline, right? Let's take, okay, let's not take yellow because it's not, doesn't show properly. Let's take a green. Okay, so this particular thing, right? Let's take a thicker line so that it shows properly. This particular thing, right? So this is called the aperture. This is called the aperture of the lens. It's called the aperture. Okay, now let's talk about the next thing. The effective diameter of the circular outline of a spherical lens is called its aperture. Okay, so this is the effective diameter. We shall confine our discussion in this chapter to such lenses whose aperture is much less than its radius of curvature, right? So what is the radius of curvature? We haven't talked about that yet. So let's talk about that first and then we'll see that point. So the radius of curvature is this particular distance, which makes sense because OC1 will be equal to OC2 and that is called the radius of curvature, because this is the radius of the sphere by which this lens is made, right? Okay, so what this line is saying? This line is saying that we'll confine our discussion to such lenses where let's take a different color. Okay, we'll confine our discussion to such lenses where aperture is much less than radius of curvature. And why is that? Why should we care about that? We'll talk about that in a future video, but for now we need to remember that our lens's aperture is much less than radius of curvature. So basically what it's saying, that lens is not very tall. The lens is not very tall, it's quite small in the y-axis. If you represent the height as x-axis, the width as x-axis and height as y-axis. Okay, so it's not very tall, it's quite small in comparison with the radius of curvature. Okay, now whose aperture is much less than. Okay, now the curvature are equidistant from optical center O, which is called the radius of curvature. Such lenses are called thin lenses with small apertures, right? So what we are studying here, what are we studying here? We are studying thin lenses. Thin lenses, it's not very tall, it's quite thin, and also it's quite thin, right, with small aperture. And why is that? We'll talk about that in a future video. Okay, now what happens to parallel rays when they incident on a lens, etc., etc. So right now I'm not going to talk about image formation. Right now I'm just going to talk, I just talked about these particular terms, and again I'm going to tell you that to best remember these definitions, you should see what they actually are and then see the bookish definition, and then you should make a definition of your own in your terms, and you should describe what that thing is to you. Okay, now we did this thing for convex lenses. We can also do this thing for concave lenses. Okay, we can do this thing for concave lenses where we have this particular circle and then we can make C1 C2 here as well. So how C1 C2 will look like? They will look like this. We can make a principal axis, and make another center which will be C2. So this is C1, this is C2, this blue line is the principal axis, right? And if I take the same colors here, then okay, let's see how will our concave lens look like. So it will look like something like this, right? Let me highlight the portion of the lens, right? So let me highlight the portion where the lens is actually. So this is the convex lens, and and this is our concave lens. Okay, this is our concave lens. Okay, so let's see the other terms. So our O, which was represented by this purple point, this is O here, which is optical center, right? And then our basically radius of curvature, which is OC1 and OC2, which are equal. Okay, and our optical center is done, principal axis done, center of curvature are done, and the radius of curvature is also done. The only thing remaining is aperture. So let's talk about aperture as well. So this will be the aperture. Okay, so these were the terms that are in the convex lens, represented in the convex lens and concave lens also. Okay, and we also talked about that how we take thin lenses with small aperture. Basically aperture is much lesser than the radius of curvature. So these are the definitions that you need to remember, and these terms will come up when we talk about image formation through lenses. So I hope you understood this, and I'll meet you in the next one. Thank you so much for watching.